Okay, so Bismillah, we'll start revising Unit 6, the thermochemistry. So let's see some questions. The first question we'll take is revising how can we find the delta H of the reaction or the change in the enthalpy of a certain reaction by using the combustion reaction or any chemical reaction that happens in which the temperature is changing. So in the first question, 100 centimeter cube of 1 molar HCl were mixed with 100 centimeter cube of sodium hydroxide. This actually is a mixing reaction, not a combustion reaction. At 20 degrees in a coffee cup calorimeter, and the maximum temperature recorded due to the reaction was 26. Calculate the delta H for the reaction. So I need to find the delta H, and the delta H is equal to the change. Delta H is equal to the change in Q, over the change or the number of moles. So the Q is equal to MC delta T. That's the mass of the substance and the specific heat capacity, and the delta T divided by the number of moles. So let's just, before answering the question, remember together that we have like many types of chemical reactions. If I have a combustion reaction, then when you are trying to find the MC delta T, then the mass is equal to the mass of the water that's being used. احنا عارفين ان chemical reaction اللي بيحصل في الcombustion, I cannot put the thermometer directly inside the substance that's being burned. So I have to do a trick, is that I will burn for myself. This is my fuel, it's burning, and then it will make a flame, and this flame will be used to heat some water. And then I can measure the temperature of this water. So I cannot put my thermometer directly inside the flame or the substance that's burn it. اللي هي مثلا any fuel, I'm burning it. I'm using it to heat some water, and then this water I'm gonna put my thermometer in and check the temperature increase or decrease. So the M here actually of the MC delta T is going to be the mass of the water being heated. And then when I measure the N at the end, it will be equal to M over molar mass. In this case, the mass is the mass of the fuel. So I have two masses here. Take note, the first mass is the mass of the water. This is the water that's being heated. And the second mass is the mass of the fuel. This is I will use to find the number of the moles later. But this is not a combustion reaction in our example. This is actually mixing of two solutions together. Mixing of two solutions together. So mixing solutions make things easy, because the first M that I need to find is actually the mass of the total solutions. So if you mix it two solutions like we will get here, I have 100 centimeter cube of the first solution, and I have 100 centimeter cube of the second solution. So simply your M is the total, is 100 plus 100 is the total, or the addition of the two solutions together. And of course, we are talking about milliliters, the same way we are talking about grams, because the density of water here is equal to 1. So if the density is equal to 1, so density equal to 1, so the mass is the same as the volume. So if I said 100 grams is equal to 100 milliliters. The third type of reaction, Mr. Tabot, about the N. Yeah, I don't need to make another mass. I will say that the N is actually the end of the limiting reagent. So if I have two solutions, I have here sodium hydroxide and I have HCl. So I can find the N of every one of them by multiplying the concentration by volume for this one and concentration by volume for this one. The one that's a limiting reagent is the one that's going to be used here to find the N. So this N is actually going to be the number of moles of the limiting reagent. So since the N is equal in both of them, because I multiplied 100 by 1 and 100 by 1, so I can use any of them. I can use this one or I can use this one. So I will simply say N is equal to C multiplied by V. That's C multiplied by V. Concentration is 1 molar. And volume, I cannot keep it as 100 centimeter cube. I have to change it into 0.100 or decimeter cube. What about the C? The specific heat capacity of the water is mentioned here as 4.2, and the change in temperature is the final temperature minus the initial. So finally, it's become 26, and initially it was 20. So 26 minus 20 is 6 degrees Celsius. By doing this, I will find the delta H that's equal to negative 50,400, and it is joules. Always the unit of the delta H or the unit of the Q at the beginning will come from the unit of the what? Of the specific heat capacity. So if the specific capacity is measured by joules, then the answer of Q will be by joules and the delta H also, and I can later change it into kilojoules by dividing it by 1,000. So the answer is going to be negative 50.4 kilojoules. So two important things besides the answer, besides the numerical value that he's looking for, very important, don't forget to focus on in the exam, is the sign. So he will give you a mark on the sign, and he will give you a mark also on the unit. So he will not look only for the value of the numerical value, he will be looking for the sign and the unit. So if the question has one mark only, then you are in trouble, because if you get the numerical value correct, but you get the sign or the unit incorrectly, so unfortunately you might lose the mark, because it's just one mark, he has no 2 or 3 marks. If there are more marks, then you will be lucky, because if you made the wrong unit or something, then it's okay. But if it is one mark, so you will lose all of it. So make sure that you also take care of the sign and the unit beside the numerical value. Okay, the second question. So our type here was of the mixing of the solution and the combustion, and we will make space here for a third type that we will take later. That will be not the mixing of the solutions or the combustion, it will be of the dissolution. If you are dissolving one substance in another substance, and then the temperature increases or decreases. So here I said that it is negative because I have seen the temperature has increased. So I know it is an exothermic reaction. That's why I've given the negative value here. If I am dissolving for the solution, I'm dissolving one substance in another substance, then I have also to say the mass is the what? The mass is mass of our solvent. So for example, if I have put some sodium or ammonium chloride solid and I have dissolved it in water, and the mass of this water or its volume is 100 milliliters, which is equal to 100 grams. So in this case, the mass of the solvent is 100 grams. But what if he told me that the mass of ammonium chloride is 5 grams, and then upon addition of it to 100 ml water, the mass became 105? Then I have to use the 105 grams. So I have two options. Either the substance will dissolve and the solvent volume or mass will not change, so I will keep it 100 grams. Or if I dissolve it, the substance, its mass changes, then I have to use the new mass or the new volume after the dissolution. So this is the first mass. What is the second mass? The second mass that's used to be divided by the molar mass to find the N. This time is the mass of the limiting reagent. And the limiting reagent is the substance dissolved or the solute. So let's just write the solute. So for example, he said, I have 3 grams of ammonium chloride, then this is the mass you are looking for. I'm always looking for two masses. Here in combustion, it was the mass of the fuel, the second mass that's used to find the N. Here, I don't need it. I just can find the N by multiplying C by V directly of the limiting reagent. And here the N is equal to mass, and this mass is the mass of the limiting reagent, which is the solute. Here it is the water. Here it is the total solutions. And the first mass here is the solvent. Again, if it is increased or not increased. Okay, let's see the second question. I have 0.600 grams of carbon. This is the question. It was mixed with 100 centimeter cube of 1 molar. We are still continuing the questions of unit 6. So we are still in unit 6. The 100 centimeter cube of 1 molar HCl was mixed. This is the same question. I'm sorry, by mistake. By mistake, the same question. This is the second one. So I have 0.600 grams of carbon burned in excess, oxygen in bomb calorimeter. I have to notice here that this is a bomb calorimeter, and instead of giving me the C, the small c, which is the specific heat capacity, he has given me the big C. So some students will by oversight will not notice that there is a difference between a specific heat capacity, and this is used in the normal calorimeters, and sometimes he will put the specific heat capacity in addition to the specific heat capacity of the water and get something called the heat capacity. This is totally different. And the heat capacity in this case he found as 10 kilojoules, and he said that the mass is 0.600. This is the mass of the carbon, and the delta T is 1.8. This is a very dangerous question because like 90% of the students will go and write the delta H is equal to MC delta T and divided by N. But note that here, this is not C, this is heat capacity, not specific heat capacity, which means that you should cancel this out and write the C only. So there is no masses to be added here. The mass is already added inside the calorimeter. So I will just say it is 10 multiply the change in temperature 1.8. Okay, now I need N. The N is the mass of the substance being burned, the same like the last time we said in the combustion. The M for finding N is equal to mass of the fuel itself. So that's a carbon. So that's 0.6 divided by the molar mass, of the carbon, which is 12. So I will say 10 multiplied by 1.8. So again, I'm saying most of the students will go and maybe they will be confused because I can find one mass. So they will say like that 10 multiplied by 1.8 multiplied by 0.6, which is totally wrong. So take care. This is not specific heat capacity, and you should not put the mass of the fuel here at all. So and they will say again 0.6 over 12 because they don't have any other options. They have two masses. So again, I don't use a mass here at the top at all. I use only C multiplied by delta T. Okay, so that's wrong. 10 multiplied by 1.8, and then the mass is used here only 0.6 over 12. This gives me minus 360. Again, the sign is negative, and the sign is negative because it is a combustion reaction. So anything he says energy is released, or he says temperature increased, so from 20 to 26, so you can see the temperature increased, or energy is released, or he said it's exothermic reaction by any means, so we have to use the negative sign in the answer. So negative 360 kilojoules, and take care again, the unit came according to the C or the delta C. The unit here was joules because I used joules in the C, the specific heat capacity. So the answer came as joules. After that, I can change it into kilojoules, it's fine, but originally it came as joules. And here the heat capacity was in kilojoules. That's why the answer should come directly in kilojoules per mole for sure of the substance. The question 3 in unit 9 is discussing how can I find delta H for another combustion reaction. So for another combustion reaction, 3 grams of ethane were burned in calorimeters. The heat capacity is 2.50 kilojoules per degree Celsius. The temperature of the calorimeter increased by 5 degrees Celsius. Calculate the heat of combustion per 1 mole. Please send the answer in WhatsApp. Send answer in WhatsApp. And the rule, just to give you the rule that you will be using, that's equal to delta H is equal to negative Q over N. I'm given the C, which is the specific heat capacity or the heat capacity. Again, I'm saying that this is the heat capacity. How did you know that this is a heat capacity? Either he said this is a calorimeter, or he said that this is the water is included already. If he said that the mass is or the heat capacity is that for the water plus the calorimeter أو الكالوريمتر بس هعرف ان دي heat capacity. So negative Q over N. So let me know the answer in WhatsApp. I'll give you 2 minutes. I need to get the sign also. Don't forget the sign and don't forget the unit. Okay, any replies? I didn't get any reply yet. Anybody almost done? The sign, yeah, Yassine, don't forget the sign. Okay. Yes, Miriam, good. Significant figures, how many significant figures? 3. Okay. Okay, Miriam. Okay, Miriam. Okay, Yassine. Type. Let's see. So I basically will multiply the C, which is the specific heat capacity, which is 25 kilojoules. And then I will multiply it by the delta T. So let me write the rule first. So I need to multiply the C, multiplied by the delta T, and then the N. The N is again the mass over the molar mass of the fuel being burned. So the C is equal to 25, and the change in temperature is equal to 5 degrees. That has been in kilojoules per degree Celsius, And here, put an answer in the chat. Yes, Anas. Yes, Anas, that's correct. Okay, so delta C. So again, the mass is equal to, he said that it is 3 grams. So I'll divide these grams by the molar mass, which is the molar mass of ethane, let's say C2H. So C2H6. So I have 24 plus 6, so I have 30. So this means that I will multiply 25 by 5 and then divide the the mass, which is 3 divided by 30. So I will get exactly minus 1250. So it's equal to minus 2150. Now multiply this by grams and over the molar mass, gram per mole, طبعا 3 grams per mole. So I get negative 1250. And since the unit here, as we said, is in kilojoules, so it will be kilojoules per mole, minus 2150 kilojoules per mole, or I can say negative 1.3 multiplied 10 to the power of 3, that's kilojoule per mole also, if I need three significant figures. Okay, the next type of the questions that we'll see in the Unit 6 is the questions about Hess law. And this question, I need to manipulate the question so that I can see what's exactly happening in the reaction. So I have multiple reactions, and let's see this question. So I have the first question saying, so use Hess law to calculate delta H for the reaction 2Fe2O3 plus 3 carbons give me 4Fe plus 3 carbon dioxide, giving the following. So I have carbon have changed into carbon dioxide by oxidation. It formed delta H minus 390, and iron plus 3 over 2 oxygen give me Fe2O3. So according to his law or his cycle, he doesn't care what is the reaction that you are using as long as you are getting the values correctly of the delta H. So he want to say that Fe2O3 plus 3 carbons give me 4Fe plus 3 CO2. I want to know what is the delta H of this reaction. If I have two combustion reactions, I have the combustion of carbon to give me carbon dioxide. So carbon reacts with carbon dioxide to give me CO2, and iron reacts with oxygen to give me Fe2O3. I know the delta H of this one. Let's say it's delta H1, and I know the delta H of this one. So this, let's say it's delta H2. So he wants to say that according to his law, it doesn't matter which reactants you started with and which products you started with. So it's independent of the reactants. The delta H is independent of the reactants as long as you start with the same thing, so and end with the same thing. So انا مش مهم عندي هنا this is Fe2O3 give me CO2، دي برضو فيها هتديني CO2 ودي برضو هتديني Fe2O3. But simply it's saying that if you want to find delta H for this one, it's equal to this delta H plus this delta H. So we need to have a look at our questions, our equations. I have equation 1 and 2, and see how can I manipulate them to reach the third equation. فمطلوب مني حاجتين. First, I need to see the direction of the equation, and number two, I need to see the number of moles. Is the number of moles the same or different? I can simply see that the direction for the first reaction should be kept the same. You should not reverse this equation. Why you should not reverse it? Because the carbon dioxide simply here is on the right side, and carbon dioxide here is on the right side. So I can see that in this equation and the required equation, this is the required equation that I want to reach to. They both have the same carbon dioxide in the product side. So this is the required equation. CO2 is here on the right side, and CO2 is here on the right side. So you don't need to reverse this equation. You only need to multiply it by 3. So multiply this equation by 3. Why is that? Because this is 1 mole of carbon dioxide, but here is 3 moles. So multiply this one by 1. So you don't look at the small reactants, usually the carbon and the oxygen, and like that. You don't look at them. You try to look at the main products formed. In the second equation, Fe2O3 is the main product. I can see it is on the product side in this time, while it is here in the reactant side. That's why I'm forced to reverse the equation. So instead of being minus 820, it will be plus. And also, this is 1 mole, but this is 2 moles. So this means that you have to multiply by negative 2. Again, you multiply it by negative because you want to reverse the equation. And you multiply it by 2 because here is 2 moles and 3 moles. So simply for the first equation, you multiplied it by 3. So you multiplied minus 390 by 3. And the second equation, you multiplied the minus 820 by negative 2. So after that, you will add the two equations together. So if you looked here, actually you did the same. You reversed this equation because the value that you have for delta H is going up here, but the value that you needed is going down because this delta H1 is equal to delta H or delta H3 that you need is equal to delta H1, but reversed because this is wanted to be going like that, while in fact it's going up. So you reversed this one, but this one you didn't reverse. And the number of moles here, you change it because this is into 2 and this is into 3. So simply adding the values together, minus 390 and minus 390 after multiplication and minus 820 after multiplication, you will do like that. The value is equal to, delta H is equal to 3 multiplied by minus 390 added to 2 multiplied by 820, the sign is reversed. So you get 470 kilojoules. You get 470. So again, look at your equations. بص على equations بتاعتك. What is their direction? Is it the correct direction? Yes, these two are in the product, so no need to reverse. This one is on the product and this one is on the reactant, so has to be reversed. And look at the number of moles. Here 3 moles, but here 1, so multiply this by 3. Here 1 mole and here's 2 moles, so multiplied by 2, negative 2 because you will reverse. And then add all the equations together to find the new answer, 470 kilojoules. يعني يا مستر, going from here to here spends kilojoules and 470, and going from here to here spends the same amount of joules with kilojoules, which is 470, and this is the Hess law. This is the Hess law. So this is a similar one, but it's a little bit easier one, saying that I have gaseous hydrogen and fluorine combined together to form hydrogen chloride. Okay, they react together to form hydrogen chloride. لما يكون عندي الانثالبي change, when I have an enthalpy change of minus 540, what is the value of the heat of formation of hydrogen fluoride? So let's try to find the answer for this one. If you can do it in 2 minutes also. And then we have time until 4:31. Try to find out how can we answer this question, and then I will come to the answer. So 4.34, and try to send this one by WhatsApp, please. Or in the chat is okay also. I'll just give you the given. The given is telling me simply that I have the delta H for with an enthalpy change, delta H of minus 540, and I need the delta H of formation of hydrogen fluoride. So simply, if some people look, will feel that, oh, already I have the equation minus 540, but minus 540 is an enthalpy change, while the formation of hydrogen fluoride is different. So you can find the answer from the definition of the formation, the heat of formation of hydrogen fluoride, because the heat of formation, if you know what is the delta H of F of hydrogen fluoride, we know that this is not the same value. This is something different. Okay, so let's keep trying to answer. ممتاز يا مريم، ممتاز. If you know the definition of the heat of formation, you will be easily able to get the answer. Any answers? تمام ياسين correct. يونت بليز زي ما اتعودنا صح؟ اوكي تمام يا انس. Still have one more left. So amount of heat released or absorbed upon the formation of 1 mole. This is a trick. If you know the definition, the delta H of formation of HF means the amount of heat released or absorbed upon the formation of 1 mole of HF. So this reaction, yes, is giving delta H, but the delta H that is formed is given is delta HR actually. So H2 plus F2 to give me 2HF. This is delta H of the reaction. This is the delta H of the reaction equal to minus 540. And this is different because delta H of the reaction does not tell you that it is a must to get it by 1 mole. This is the only delta H or enthalpy change أو تغيير في الانثالبي بتاعت الرياكشن اللي بتقول لك it's not necessary to find it by moles. لكن في الدلتا H of formation you must find it by moles. So instead of having 2 hydrogen fluoride, you need to find it for 1 hydrogen fluoride. Okay, simply, Mr. If it is minus 540 kilojoules per mole, sorry, minus 540 kilojoules, he did not say for mole for sure. Then how many per 1 mole of HF? I will just make cross multiplication, means that I will divide it by 2. So minus 540 divided by 2, you get minus 270 kilojoules per mole. Now I will say per mole. Take care. This is the unit is per mole for the enthalpy of formation, but for the enthalpy of reaction, as you noticed, he said here minus 540 alone. He did not say per mole. So again, for the enthalpy change of the reaction, you are not required to say by mole, because this is just the amount of heat or released or absorbed upon the reaction done. Okay, another type of the questions is when he is asking to find the delta H of a reaction by giving me the delta H of formation of some of the reactants and products. So this is the second type. This is the next question. So if I have been given some delta H of formation of reactants and products, or products, then I am asked to find the delta H, the total delta H of the reaction. Let's try to find how to do this. Okay, this should be an easy one, Mr. Just remind us each other that in order to find the delta H of the reaction, you will just subtract the delta H of formation, so that sum or the total for all of formation of, is it reactants minus products or products minus reactants? Anybody remember? Is it products minus reactants?
Products minus reactants.
Yes, it is the delta H of the formation of addition of all the products minus the delta H of formation of the reactants. So add all the products together and subtract it from all the reactants if there is more than one for sure. And we'll try to find the equivalent. Please find the correct number of significant figures also, and the correct number on the correct unit. And the answer should be in 2 minutes, either in chat or WhatsApp, please. It was fast. Okay. Okay. Joule is in capital. Okay. Mister, you're just giving an answer about the calculations. Yes, because you have to be accurate in calculating and putting the number of moles correctly. Don't forget the number of moles to get the correct answer. So add all the products together and subtract it from all the reactants.
مستر،
Mhm.
بس هما مش مدينا الرقم لل O2.
Okay, and why is that? Because O2 is an element. صح؟ فاكر احنا لما قلنا في الاس وفي الجي بيدينا values، لكن في الدلتا اتش take care delta H the enthalpy change of formation of delta H of element is zero. صح؟ It is zero for
اه.
an element because how much heat you need to make oxygen from oxygen? It is zero. It's already oxygen. Okay, that's correct. Miriam also correct. جميل. Okay, very good. So must look, you got it correct. -2214. Yes, that's correct. So simply I will just say that the delta H is of the reaction is equal to 3 multiplied by CO2 because CO2 is my first product. So I will just say these are the products, mister, and which is CO2 and H2O. So I'll put them here at the beginning, and then I will subtract them from my reactants. Where are my reactants? These are my reactants. Oh, mister, you said the opposite. So sorry, this is the correct minus the products minus reactants. So this is correct machine time. So I will just say, what is my first product? My first product is CO2. So I will multiply it by 3. So 3 moles. Take care. Don't forget the mole. 3 moles of CO2, which is minus 390. So 3 multiplied by minus 390. And then add it because we said the sum. The sum. Add it to the other reactant, the other product, which is H2O. That's minus 286, but multiplied by 4 moles. So 4 multiplied by minus 286. Be very careful while you are making the brackets, okay? And then you will subtract this from the reactant. What is the reactant? The first reactant is C3H8, which is minus 100, and then there is no different number of moles, so it is just minus 100. And then as oxygen is zero, take care, oxygen is zero because it's element. Every element when you are doing it, it will be zero. It will be zero for the delta H. Since we already finished chapter 9, or sorry, unit 9, then we can also say that don't forget that the delta G is also calculated by the same way, and delta S is also calculated the same way. So it's equal to the sum of the delta G of the products minus L delta G of reactants. And for S, it's also the sum of the delta S of products minus the delta S of reactants. This is what we took in unit 9, right? The only difference is that it's not necessary that the delta G or delta S entropy of the Gibbs energy of the elements will be zero, but just have to follow what you are given inside the question values. So inside the question, have a look. If it is given a certain value, then it's equal to this value. Don't say it is zero. So you are given that S of oxygen is 50. Don't say it is zero. Say it is 50, calculated as 50. Let's see some more questions. After a very short break for 2 minutes. So this is question number 7. Consider the following reaction represented by the equation. Based on the information above, what is the value of enthalpy change per 1 mole of NO? So I have 2 equations already. And then I need to find the third equation. So I need to find the third equation. Or I need to find the value for 1 NO only. That's an easy one. You can type the answer also if you wish in the chat or in the WhatsApp. WhatsApp will be mainly if you have like working you want to show. Otherwise, you can just type it in the chat. That's easy one, right? No need to do any questions. Okay, try again. So this is the 2 equation. Just have a look what happened here and what happened here. And just have a look also. This is NO and this is NO. So I'm helping you. Correct meaning is good. No, no, you see. So try again. I'll give you 1 more minute until 4:49. Try it again. So I need to see how I play with the equations so that I can reach the third equation. I need to say how I will play with this one. تاني أبص على الإيكويشن إيه؟ Direction and look at the direction and look at the number of moles. So look at the direction and look at the number of moles. It's a little bit tricky, Yasin, because after answering, we have to do one more thing. Yes, that's correct. So it's a little bit tricky because after answering, you need to do one more thing. Yes, correct. Yes. Okay. Okay. So let's have a look again. The first equation, N2O4 and NO2. I can see, Mr. that the first equation, both of them has, and the third one, both of them has N2O4. The only difference, yeah, Abdurrahman, is in the direction. Is the direction the same or opposite direction? I can see that here it is in the reactants, but here it is the product. So I need to form equation number 3 from equation 1 and 2. Equation 1 has to be reversed. Why? Because the reactant here, N2O4, is in reactant here, but here it is in product. So I need to reverse it. So I will take this minus 1 and plus 55. So I will take this plus 55 and reverse it. It will become minus 55. So equation 1 again, it will be minus 55. Why? Because it is reversed. Second one, do I need to make any multiplication or division, Ya Abdurrahman? While the number of moles here is 1 and here is 1. Well, I can see the number of moles 1 in both of them, so no need to change. What about the second equation, Anas? Is it the same or different direction? You see the main compound here is NO and NO. So in 2 and 3, it is in the same direction. Here in the reactants and here in the reactants. And the number of moles is the same, 2 and 2. So just keep the value as it is. It will become minus 116. Okay, what happens when I add the two values together? مش احنا قلنا يا مستر I will add the two values together. So after adding the two values together, what do you get? You get minus 171. But take care, that was very tricky part. So I rarely see a question which is tricky like that, because this is minus 171. Yes, it is for the correct equation, but he asked what is the value for the enthalpy change for 1 mole. So the equation number 3 that we found is minus 171. That's correct. But for 2 moles of NO, for 2 moles of NO, and then you will have to divide this by 2. So divided by 2 is equal to minus 86 kilojoules, which is the correct answer. Okay, so kind of a very tricky question, because most people will just add the values and then get the answer. Here there is an extra step that has to be done. Okay, one more question for the same idea. Oh, that's different. Okay, this is a calorimeter equation. When 20 milliliters sample of 0.50 molar NH4 2S and 20 milliliter sample of 0.50 molar ZnO3 are mixed in a calorimeter, a reaction occurs. Find if the temperature increased from 21 to 25. This is very similar to the first question we answered together. اللي كان فيها 100 ml and 100 ml if you remember. What is the experimental value of delta H? I'm going to help you again. The delta H is equal to negative Q over N. The Q requires M. The M is the masses, but a mass of what? We mix it two together. Try to remember what did we say. And then also the N is the mass of what this time? Or the N of what? So just a reminder from the first question, when we found the mass, what was the mass equal to? And when we found the n, we said the n will be the n of the what? The n of the what? We said that it will be the n of what? This is just a hint to help you. And this is the main question if you were answering and I interrupted you. Okay, I'll give you 3 more minutes or 2 more minutes until 4:56, 4:57. So I use M here, the masses, and I use N, which is the number of moles. And don't forget the sign and the unit, okay? The sign and the unit. Yeah, I didn't get any answers yet. Is it so difficult? Okay, one answer is here is except for the sign. Except for the sign. No, the sign is correct. Your answer is correct. Sign is, yeah. Answer is correct. Miriam, look for the sign. Anas, you are fine. Yeah, you are right. Can you see what happened to the temperature? Did it increase or decrease? Is the temperature increase or decrease? And does this mean exothermic or endothermic? So if the temperature increases, it doesn't mean plus. It means what? It means that this is an exothermic reaction. Yes, correct. Correct. This means an exothermic reaction. Yes, yes, and you are correct also. So, okay, we still have one more minute remaining for 57. Okay, so simply, Mr. Delta H is equal to the negative Q multiplied by, which is negative MC delta T divided by N. So MC delta T is equal to what, Mr. Is equal to the mass, which is the mass of the total. احنا قلنا when I'm making mixing, لما بعمل mixing of two solutions, the mass is the total of the two solutions. The mass is the total of the two solutions, and N is the limiting reagent, is the number of moles of the limiting reagent. So as we said, this is negative. So that's negative. Negative again because of exothermic reaction, because the temperature has increased. If the temperature increased, then it is an exothermic reaction, so it is negative delta H. If the temperature decreased, this is an endothermic reaction, so it is positive delta. Take care, the sign is as important as the numerical value. So negative M, which is negative 40, the total of 20 plus 20. So that's equal to 20 plus 20 or 40, multiplied by the C, the specific heat capacity, which is 4.2, multiplied by the, sorry, change in the temperature, which is 4 degrees Celsius. Divide this by the number of moles of the limiting reagent, which is the limiting reagent. To find the number of moles of the first one, 20 multiplied by 0.5 over 1000 for sure, and 20 multiplied by 0.5. So they have the same one, and we said if they have the same one, so I will just pick any one of them, right? So I'll just pick any one of them. So for both of them, it's equal to 0.01. So both of them is 0.10 moles, because both of them are having the same number of limiting reagents. Both of them have, because the ratio is 1 to 1 in them. Type. So 40 multiplied 4.2 multiplied by 4 and the negative sign. So I'll get the value as negative 0.67 kilojoules per mole of the reaction, like you said. Okay. This one is for the dissolution, وزي ما قلنا when you make the dissolution, take care the mass is the mass of the substance that's added plus the solvent itself. لو حصل تغيير, so if he said it's completely dissolved and there is no change in mass, so you have just to add the to put the number of the solvent itself. Okay, we'll give 2 minutes. بما احنا كنا بنرغي شويه, او we say until 5:03. And don't forget the sign. Also, the unit has been added, but don't forget the sign. If you want to show me your working, you can send it by WhatsApp. I'll be grateful also. So the mass this time is the mass of the solvent, you understand? The mass of the solvent. Let's see, adding the 10 grams changes anything or no? Okay, let's see if adding the 10 grams changes anything or no. That's correct. ممتاز يا عبد الرحمن. Very good. That's the fastest. Okay, great. Thank you, عبد الرحمن. That was the fastest. Okay, that's great. Correct. تمام. P is always small and G is capital. Okay. Okay. Other champs. Huh. Okay, so Mr. Simply, I will put the masses. So take care. I will put the masses together. I have to add the masses together. 150 grams has been added to 10 grams of sodium hydroxide, which give me 160 grams in total. So it will give me 116 grams of total. When I multiply this one, this is Q is equal to, does the temperature increases or decreases? It becomes 39.6. So this is negative MC delta T over N. So equal to negative 160. So let's make this clearer. So we are not short of place. So I will say negative 160 multiplied by the C, which is 4.18 multiplied by delta T. The change in temperature equal to 16.6 degrees Celsius. I have here Celsius. I have here, by the way, joule per gram per Celsius. So joule per gram per Celsius and 160 grams. So these all are gonna cancel out. And the answer will come out as joules for sure. It will be 11,000 and 100 joules, so 11,100 joules, and divide this by 1,000 to get 11.1 kilo joules, which is the answer, which is our answer on this. Okay, this is a different question for the energy diagrams. Okay, let's try simply to find if the reaction is exo or endo. That's what simply is trying to know. Is this an exo or endothermic reaction based on the values? Then you can decide which is the diagram, which is correct one. Try again. Give it another try. So again, we say the products minus reaction. Give it another try. Okay. I think I did not get any correct answer until now. Until now, I did not get any correct answer. Can you try again? Okay, so somebody help me in answering this one. How can we find the delta H values? Then we can look at in the table. So what is the delta H? This is the delta H of the products minus reactants. So what are the products? What are the products? It's NaCl. So NaCl, which is 2 multiplied by minus 410, correct? And then what is the other reactant? The other reactant that I'm talking about the products, so products in ACL, and this is 0 for sure. Somebody give me a new answer. Yeah, that's the last one. Yeah, the last one is your correct answer is last one. So 2 multiplied by minus 410, and then I will subtract this from my reactant, which is NaClO3. So it will be minus 370, but this is multiplied by 2 as well. So 2 multiplied by minus 370. What is the value that you get? ما حدش بعت لي الوركينج خالص. So what is the value that you get? Q multiplied by 410. So that's equal to 820 minus 740. That's equal to plus 80 or minus 80. Let me see here. 2, this is negative, right? I didn't put the sign, me myself. So 2 multiplied, so minus 820 minus 370, so plus 740. This is the dangers of the signs. So minus 820 plus 740, that's equal to negative 80. So the answer can be either A or C, but it cannot be B or D because both cannot. So A or A or A or D, A or D. It cannot be B or C because B and C they are 40. So 40 is incorrect answer. And we are looking for an exothermic reaction in which the products are more than the reactants. The products are more than the reactants. The products are less than the reactants because the energy has been lost. So that's why the answer is A. So this one is exothermic reaction because it is negative, while here it is endothermic reaction. The amount of heat in the products is more. So this is wrong answer for sure. Okay, that has been an easy question. So take care if you miss such an easy question. This is a pity of the exam. So let's see some of the questions in the bond enthalpy. So bond enthalpy, I will try, this is the third and last method to find the delta H of a reaction. The three methods are either by calorimetry or by Hess cycle. And the third method that we will use right now is finding by the bond enthalpy. So the bond enthalpy is just adding the enthalpies of the reactants together without missing anything. And then we will just subtract. But what we are subtracting this time, we are just subtracting, finding the delta H by saying that it's equal to, so delta H is equal to the total of the bond enthalpy of what? minus what? total of bond enthalpy of what minus what. في حد كده يشرفنا بصوته الكريم، بدل ما انا عمال بقالي ساعه وربع بتكلم وزوري ناشف. حد يقول لنا البولد انثالبي اوف وات ماينس وات.
reactant minus product.
ممتاز ممتاز. It is the reactants minus products this time. So to find the delta HF, just add all the bond enthalpies of the reactants and subtract it from the products. And I'll give you 3 more minutes to find this. If you want to find the write the working also, please let me know على WhatsApp. Okay. What is the answer? The answer is until now. Is it that difficult? Or nobody wants to know? Okay. So, first answer. What about the sign? Can you have a look at the sign? The number is correct, but the sign, can we look at the sign? Can you give it a try again, Anas? Miriam, your number is correct, but the sign is. Can you have a look at the sign again? Yasin. And can you have a look? Just make sure that you are trying bond by bond. You don't lose any bond. It's easy questions in the exam. Very easy. You should not lose any mark here. Bond. Okay, I got one more answer, which is yes, correct. Marine. Yasin, no answer. Abdurrahman, can you try? Okay, time is up. So we'll have a look. Exactly, it is 413. Okay, I got an answer again. Okay, so let's have a look why it's not coming correctly. So I have here the reactants, Mr., which is this one, the yellow one, which is, try to put it on the one. So 413, 413, that's the CH, but this is multiplied by how many times? This is multiplied by 1, 2, 3, 4, 5. I got one more answer here. Very correct. Okay. So 413 multiplied by 5 in addition to the CI, which is 240. And then I will subtract this from the reactants, which is 615. And this is added to CH again, which is 413 multiplied by 4. And that's added to HI, which is 299. Let me see, did we miss anything? Comments? So, in the 2, 3, 5, 9, 2, 5, 6, 3, 5, 5, minus 2, 2, 5, 6. So 2 negative 1, 7, 1. Negative 1, 7, 1. Was it the composition? I didn't even get it correct. So 6, 1, 5. I think I missed something. 413 multiplied by 5 plus 240. Oh, there is one more here. This one, year one, we didn't add 348. I didn't add this one, 348. So 2395 is actually 2743. 2743. And here we have 615 minus 2566. 727. So this time it's plus 177. Still not correct. 413 multiplied by 5. 5 plus 348 plus 240 is minus this one is 615. So let me just call them plus 348 plus 240. This is 2653, 2653, 2653 minus 2566. So 87 plus 87. Okay, how difficult it is? Very difficult in making the math correctly. Have to be very careful. I get it from the third time only. Plus 87. So the addition of all the reactants give me 2653 and all the products 2566 is positive 87. Very tricky numbers. Just have to be very careful about them. And our last question for today is this one. Different kind of question. This maybe is the last question, maybe. So based on the information above, which of the following samples will undergo the greatest temperature change if each sample absorbs the same amount of heat? Okay. And I need this in WhatsApp, please. So you show me how did you do the working for this one. Which one will undergo the greatest temperature change if each sample absorbs the same amount of heat? And if they all have the same Q. Okay, any answers ولا كله lost energy خلاص؟ ما عاد في energy. So just to give you a hint, try to find the Q because he said that try to find the temperature change. He is saying the same Q. So if you have Q is equal to negative MC delta T, for example, if the temperature increased, and he has given the masses. So is it which of the following samples will undergo the greatest change? So look at the C. The C is different, and the delta T. I need to find the delta T. The amount of Q is the same. So if the Q is the same, what will be the answer? I see Q is equal to MC delta T. الدلتا T اللي هو بيسأل عليها is equal to what? What's delta T? You see what's delta T? Q over MC. طب أنا عندي الماس بتاعت كل واحدة وعندي السي بتاعت كل واحدة, so I can calculate. So for graphite, for example, the first one, graphite, the sample is 1. So is equal to Q. Let's see all the values. يعني أنا حطيت value معينة, هحط ال Q واحدة, هقول 1 ليهم كلهم. So it is 1 over MC. The mass is 1 and the C is 0.71. هيطلع كام الحل? So you will find them one by one like that. 1 over 0.71, that's equal to 1.40, the change in temperature by degree Celsius. The second one, aluminum, will do the same. It will become 1 على 1.40. one على 0.90. So aluminum is equal to 1 over 0.90. انت ليه حطيت 1 هنا يا مستر؟ ما هي الكيو بتاعتهم واحدة فيهم كلهم. So I put any number which is fixed. So this will be 1.11 degrees Celsius. A sample of Fe, that's equal to Fe يعني 2 grams المرة دي. 1 على 2 multiplied by iron يعني 1 على 0.9. 1 على 0.9 في نفس الفاليو اللي هي 1.11 degree Celsius. خد بالك السؤال ده تريكي شوية. Who gets the answer? Anas gets the answer as A. Yeah, that's the correct answer, Anas. Thank you. And the last one is 1.1 over المرة دي 3 grams في الزد ار يعني 3 في 0.28. 3 by 0.28, 3 multiplied by 0.28 is 0.84. 1 على 0.84 is equal to 1.19. 1.19 This is for the ZR. So the one that goes the highest temperature change is simply graphite. It's simply graphite. It has the temperature has changed to become 1.40. خد بالك انت كان ممكن بدل ما تقول 1 over كذا كان ممكن تقول 2 over كذا فيهم كلهم او 3 over كذا فيهم كلهم او 10 over كذا فيهم كلهم. انت حطيت اي value للكيو بس. Okay, so that was the last question for today. We'll get some more questions on the next Tuesday. And thank you so much for participation. Thank you. See you next time, inshallah. Any questions? I'm open until 5:30. كله خلص بطاريات؟ اوكي. السلام عليكم.